Imagine trying to have a conversation with every sentence forces you to reread the entire discussion so far that you had with that person. That's what attention does. And for a long time, it did it in the most expensive way possible. So the question became simple. Can we make attention cheaper without making it weaker? The answer is grouped query attention, or we can call it GQA. To understand GQA, we need to revisit how multi-head attention works. In a standard multi-head attention, each head has its own queries, its own keys, and its own values. Every head computes attention independently, as also you can watch this video for multi-head attention. This gives the model multiple perspectives, but it also multiplies memory cost. During inference, each head needs its own keys and values, which should be stored in KV cache. As models scale to dozens of heads and long context windows, KV memory explodes. The key observation behind GQA is subtle. Not all heads need independent keys and values. In practice, many heads learn similar attention patterns. Queries benefit from diversity. Keys and values often do not. So instead of giving every head its own keys and values, we can share them. The idea led to multi-query attention, where all heads share a single set of keys and values. Multi-query attention drastically reduces memory usage, but it can hurt quality. Sharing too aggressively removes expressive power. Grouped query attention is the compromise, especially if you're really worried about what you get out of the money that you paid for the models, no matter which company you're subscribed to. You want the highest quality possible. As you can see, also one of the viewers commented in the other videos that you always want the best possible out of the money that you paid, and it is reasonable. So if you want to save the cost here, we want to make sure that the quality remains. In GQA, queries still have many heads, but keys and values are grouped. For example, 32 query heads might share only 8 key value groups. Each group serves several query heads. Queries remain diverse. Keys and values are reused. This dramatically reduces KV cache size, while preserving most of the benefits of multi-head attention. Let's look at this mathematically. Every query head H attends to a shared key value group called G. The attention equation stays the same, only the parameter sharing changes. This change is almost invisible from a modeling perspective, but massive from a systems perspective. During inference, KV cache memory scales with number of KV groups instead of number of query heads. This enables longer contexts, more layers, and faster generation. This is why GQA is used in modern production models. LLaMA 2 uses GQA. Mistral uses also GQA. Many high-performance open models use GQA as well. Without it, long context inference would be impractical. There's also another important insight. GQA works especially well because of ROPE, or rotational positional embedding. If you want to learn ROPE specifically, you can watch this video. We will not go through ROPE again. But the task of ROPE is that to encode relative position directly into queries and keys. Sharing keys across heads does not destroy positional awareness. Distance relationships are preserved. This is a recurring theme in modern architectures. One optimization only works because another already exists. ROPE or ROPE enables GQA. KV cache enables long context inference. Infinite attention enables memory scaling. Together, they form a coherent system. Of course, GQA is not free. Reducing number of key value groups too aggressively can hurt performance. The model loses some fine-grained attention patterns. That's why grouping is a design choice, not a fixed rule. And of course, as a user, you don't like the model that you are paying for is reducing in quality. But empirical results are clear. A small drop in expressiveness buys a massive gain in efficiency. For real-world systems, that trade-off is worth it. So when you see a model with long context and fast inference, chances are it's using GQA under the hood. You are not seeing less intelligence. You are seeing a smarter allocation of computation. If you have any questions or any experience on GQA that you want to mention to all the viewers, don't forget to comment it down below. If you like such contents, don't forget to like this video and subscribe to the channel for the next videos. Until the next video, good morning, good afternoon, and good evening. Bye.